All right, so the nice thing about geometric sequences is now that we've done arithmetic, a lot of the basic principles are going to be the same in terms of like how we label the first term and things like that. So in a geometric sequence, the difference, right, when we had arithmetic, we were adding something every time. What were we doing for geometric? We talked about it already. We're going to be multiplying by the same thing to get the next term each time. So there's a constant multiple, or a common multiple, actually we usually call it, between consecutive terms. What does consecutive mean again? One after the other. Term 5 and term 6 are consecutive, one after the other. Okay, so in this very first one, my first term would be 3. And what would be my common ratio? What are we multiplying by each time? 2. Or multiplying by 2. So we use the letter R for common ratio as opposed to common difference. Term 1 here is 1, and our common ratio, -5. We're multiplying by -5. Good. Each time. Term 1, 64. And what are we multiplying by each time? So it might be like, it's easier to see, I'm sure, you're dividing by what? You're dividing by 4, but in common ratio, it's always what we're multiplying by. So dividing by 4 is the same thing as doing what? Multiplying by 1/4. Multiplying by 1/4. So if you want to divide by 2, you multiply by 1/2. It's the same thing. Divide by 4, multiply by 1/4. Same thing. Okay? So the reason why it's common ratio is because what we're multiplying by, you could get by taking your second term divided by your first, or your third term divided by your second. So do you see here, where's my pointer? Here it is. Okay, so 6, oh, my pointer's not really working. 6 divided by 3 would give you 2. 12 divided by 6 gives you 2. That's why it's called a common ratio. 16 divided by 64 is 1/4. Or 4 divided by 16 is 1/4. 1 divided by 4 is 1/4. So that's why it's called a common ratio, is because you can take term 2 divided by term 1, or term 3 divided by term 2. When you divide the consecutive terms, you get what you're multiplying by each time. And so forth, and dot, dot, dot. So finding the ratio of the two consecutive terms. Try and zoom in a bit here. Okay, so the first term of a geometric sequence. And then second, I'm just going to label these 3, term 3, term 4, and term 5 here. Okay? So just kind of the same idea, little bit different, but same idea. In arithmetic, we were adding d each time, right? But in our geometric, we're multiplying by r each time to get the next term. So notice that term 1, well, that's just term 1. Term 2 is term 1 times r, right? Because you're multiplying by r 1 time. Term 3 would be term 1 times r how many times? 1, 2, r squared. R times r. Okay? Term 4, to get to term 4, you start at term 1 and you'd have to multiply it by r how many times? 3 times. So do you see how many times we're multiplying by our common ratio is 1 less than the term number? Same idea as when how many times we were adding d was 1 less than the term number. And so that's where this formula comes from. Any term can be we can get any term by taking the first term and multiplying by r, well, how many times? N minus 1 times to get there. So that's the formula. On your formula sheet. Excuse me. You don't have to memorize it. Yeah, there we go. So, let's just start finding T5, okay, for this geometric. So we need two things in our formula. Well, we need three actually. Term 1, R and N. So what's the first term? 2. Common ratio. 6 divided by 2 is 3. 18 divided by 6 is 3. And N, 5. So let's plug it into the formula. T5 is equal to term 1 times R to the power of N minus 1, so 5 minus 1, or 2 times 3 to the power of 5 minus 1, or 4. Okay, when you enter this in the calculator, it depends on the type of calculator you have. So most of you have one that probably looks like on the screen or newer. If you have an older version, when you do to the exponent, it gives you like the hat and brackets, right? It looks like 2 times 3 hat bracket. Is that right? Does it give you a bracket? Yeah, okay, good. So you would have to go 5 minus 1 in brackets for it to do it properly. With this calculator here, if it automatically just raises it, then you can just type in 5 minus 1 and you're good to go. And that's 162. Notice that you can't go 6 to the power of 4. You can't multiply these first and then raise it to the exponent. Why? Why can't I go, why is that not the same thing as 6 to the power of 4? Do you know why? You just know you can't? Grade 10. BEDMAS. Yeah, it has to do with BEDMAS and exponent laws. So you have to apply the exponent before you can multiply. That's the number one reason. And if we want to like combine these, like that it would only work if your first term and your common ratio were the same. And in that case, you would add the exponents. So for example, sometimes this happens, and you might see it on a test. If my first term, say, was 4 and my common ratio was 4, okay? So then your general formula would be your first term times your common ratio to the power of N minus 1, right? But what's the exponent of 4 if you don't see it? 1. So if the bases are the same, what can we do to the exponents? And they're being add them, right? If they're being multiplied, we add the exponents. So 1 plus N minus 1, guess what that equals? Just N, 4 to the N, okay? So sometimes on a test you might see this, where the general formula looks really different than where we started. Because if the first term and the common ratio are the same, we can use exponent laws to combine those. But that only happens if those bases are the same. The bases aren't the same here. Okay, sorry, I got way off track. Where is the 162? Okay, one more note can we add on this page? I don't know if you have room for it. Maybe you do. I don't know. Hopefully. Okay. If you graph a geometric sequence, do you remember what an arithmetic sequence looked like? It was linear, right? It followed that linear. Your slope is the same thing as your common difference because you're increasing by that same, it's the same rate of change each time. It's not the case in geometric. It's way more exciting. Okay, so let's just graph this. I'm going to go up by tens. 10, 20, 30, 40, and we'll estimate here approximately where the dot's on. So term 1 was 2. Term 2 was 6. Is that right? Okay, so that's kind of close to 10, but maybe a little lower. Okay. Term 3 was 18, closer to 20. And term 4, what's term 4? Did we show it? No. 18 times 3 is 54. What's 18 times 3? 54. Is it warm in here? Yeah. Okay. Which is like nice and all, but then you're gonna fall asleep on me. I like it nice and cold. Are you comfortable or are you warm? No opinions? We don't care. Does that look linear to you? No. So that shape is actually something you're going to learn a lot about in Math 30, and that's called exponential. So geometric sequences are exponential. If you take biology, then you know a little bit about that, right? Exponential growth. And that's what a geometric sequence is. It's growing exponentially. Okay. Definitely too warm in there. Okay, we can turn the page. How long is this? Oh, is this a long one? Oh, 2 more pages. Cover up my sleeves. How many terms are there in the following geometric sequence? Okay, tell me what we know here. T1 is 2. R is 3. This looks very similar to the last question. And what else do we know? Tn, our last term. Good. Tn. And we are looking for, how many terms stand for? N. We're looking for N. Good times. Okay. So this is fun. I'll show you why in a second. So let's sub in what we know. Oops, 1,458 equals term 1 of 2 times 3 to the power of n minus 1. Okay, so where would I start with this, solving for n? We've never had to solve for an exponent before. So this is a whole new territory. Yeah? Nope. Yeah? So can we multiply 2 and 3 together? Right? Because this has an exponent, we can't. Yeah? We want to isolate n. So our first step would be to not subtract. What's operations here? Divide by 2. This is multiplication. So we want to leave the base by itself. So you've never solved for an exponent before. So this is a whole new territory. The first thing we want to do is isolate that base. It's all about, no, I won't say it. It's this close. 729. Okay. So now we've isolated the base. You want to get the base by itself. Okay. Now we're in trouble. So to algebraically solve this, you'd actually need to use something called logs, is one method. And you don't learn about logarithms until grade 12 math, okay? You might use them in biology, but it's just like, here's what you do, plug it in, and they don't explain what logs are. Another way we can solve is by making the bases the same. So is 729, can we express this as 3 to the power of something? Okay, is 3 to the power of something equal to 729? So we need to do a little bit of guess and check. So we want to turn the bases into the same. I'm just going to write. So I need to turn this into a power with base 3. Okay, so 3 to the power of what is 729? Yep. Let's check. It's 3 to the power of 9, 729. Nope, let's try another one. 6. Sure thing, 6. So instead of writing 729, I'm going to write that instead as 3 to the power of 6. And now 3 to the power of 6 equals 3 to the power of n minus 1. So this is good. Now we have two bases. You just have the bases equal to each other. That means their exponents are also equal to each other. Does that make sense? Do you see that? So because their bases are the same, and this is an equality statement, we can therefore say that 6 is equal to n minus 1. Because those are equality statements. So we can set the exponents equal to each other now because they have the same base. So therefore, n has to be 7. So in grade 11 math, we only can give you problems where we can make the bases the same, where n is going to be a whole number as your answer, not a decimal. That's grade 12 math. Yay! So you get to make the bases the same. So solving for n is a little bit trickier when it comes to exponential functions, eh? Good times. I see. Someone needs to turn their volume off on their phone. Okay. Fine, maybe it's me. All right. Find two terms between 3 and 375. Find the two terms between 3 and 375 if the sequence is geometric. Okay, so remember we had two methods at looking at this when we did arithmetic. I'm going to show you again two methods. So what was the first method we used in our arithmetic? Do you remember what we did? For given random terms. Treat 3 as, yeah, the first term. So method 1 was treat 3 as term 1. Then 375 would be what? T4. Okay, so that was the first method. We pretend the first two terms don't even exist, and we say, hey, this is my term 1 and this is my term 4, and let's just ignore this for now. Pretend it doesn't even exist. We can work backwards later. Okay, and then we use our new formula. So T of n equals term 1 times r to the power of n minus 1. So what do we know? What's T of n? What's my last term? 375 equals first term 3. Do we know our common ratio here? No, so that's going to stay as r. And what's n? What's our last term's n value? 4 minus 1. Okay, so we're solving for our common ratio. We need to figure out our common ratio, because if I figure out my common ratio, I can figure out the middle terms, I can figure out the first term, like life is good. So, where do I start? I'm going to say it's all about the base. We need to get the base by itself, the r by itself. So divide by 3. I didn't sing. At least I didn't sing. I'm sure I'll treat you to some singing later on this semester, but not yet. Something to look forward to. What does that equal? 125 equals r to the power of, can I write it as something else instead of 4 minus 1? 3. Okay, this is something you should know how to do. Not square root, cube root. We want to get rid of the cube, the power of 3, and the opposite of an exponent of 3 would be cubic root each side. Which gives us 5. Cubic root of 125 is 5. So there's my common ratio. Okay, that's the first method to getting the common ratio. The second method is kind of build your own formula. So let's erase this for a second. So method 2, like we know term 3 and we know term, I can add 4, 5, term 6. Okay. We know term 3 and term 6. So we can build our own formula. Term 6 is equal to term 3 times r. How many times would I have to multiply by r to get there? Nope. 3 hops. Times by r 3 times. So if I multiply by r 3 times, it's the same thing as multiplying by r to the power of 3. And the difference of the terms would also give you how many times you're multiplying by r. Okay? And so from there, it's essentially the same formula, right? Because term 6 is 375. Term 3 is 3 times r cubed. Is that not the same thing as what we did here? I don't know, is it? Divide by 3, and then cubic root it. It's the same thing, and so forth. God, 5 is equal to r. It's the same thing. So both methods work. It's really up to you how you want. You can either build your own formula or treat term 3 as term 1, and then work backwards. So now we can actually answer the question. It says find the missing terms in between. So we're just going to multiply by 5. 3 times 5, 15. 15 times 5, 75. If we wanted to work backwards, what would we have to do to get those other terms? Divide by 5. What's 3 divided by 5? You could either write it as a decimal or you could write it as 3 over 5. Divide that by 5 again would be 3 over 25. Alrighty. We're not even at the good stuff yet. I'm sorry this is a long one. I think you could try this one. Well, I'll get you started and I'm going to get you to solve for r on your own, okay? The beginning of it. The third term in a sequence is 2 and the seventh is 512. So 1, 2, 3, 4, 5, 6, 7. So I'd like you to solve for the common ratio. Okay? The example above we just did, very similar. Start with solving for the common ratio. That's all I want you to do. So I'm just going to write a little note there. So it's plus or minus 4. So if the index is even, the r is plus or minus. Because your calculator will only give you the principal. They won't give you both, the positive and the negative. It'll only give you the positive. Okay. Now, this question is actually asking us to find the general term. What is the general term? You guys remember what the general term is? Just T of n. It's the formula. We just want the general formula for the sequence. Okay, so in order to write the general formula, so that's when you leave n as n, we need to know your first term and your common ratio. No matter what, whether it's a positive or a negative, the first term will it become positive or will it be negative? Doesn't matter, or it'll always be positive. So if you divided by -4, this would be a negative. What would be the next one? Positive, and then it's positive, right? So it doesn't. Both cases are going to be a positive first term. So let's just figure it out with. So there's two cases, right? if r is positive 4 and if r is negative 4. Okay, so let's figure out each one. Positive 4, so let's fit in the missing terms. 2 times 4 would give you 8 times 4, 32 times 4, 128. No? Oh, 8 times 4? Yeah, 128. Yeah. Right? 8 times 4? Yeah. 32. Okay, the other way, divide by 4. What's 2 divided by 4? 1/2. What's 1/2 divided by 4? Nope. 1/2 divided by 4. Oops. 1/8. Good. 1/8. If you want to change it, oops, I'd have to put this in brackets. I should put it in brackets. Divided by 4, and then math, enter, enter. 1/8. Okay. Or if r is negative 4, what would be the only difference in our values here? There'd be negatives. So where would the negatives be? At negative 8, and negative 1/2, and negative 128. So we have, no matter what, our first term will be positive 1/8. So if r is equal to 4, if r is equal to negative 4. There's two general formulas. So the first one, if r was equal to 4, term 1 is 1/8 times 4 to the n minus 1. Or 1/8 times negative 4 to the power of n minus 1. It could be either or as an answer. Okay? That's a tough one, but I needed to talk to you about how if the index is even. Often your questions will probably be odd indexes, so you don't have to worry about that. When we cubic root a negative, it's a negative. You cubic root a positive, it's always positive. It's just if you take the square root, the fourth root, the sixth root, the eighth root at even index of a positive number, could be plus or minus. Okay? All right. So now we can get into the tougher questions. Feel like that wasn't a tougher question? Wow. How's your head today? It's a lot for a Monday, or I guess Tuesday, but after like a long weekend for some of you. Some of you were here yesterday, so you didn't really get a long weekend. Okay. A car's value depreciates. What does it mean to depreciate? Lowers. It lowers its value on average by 15% each year. If a car's original value is $35,000, determine the value after 5 years. So there's a whole bunch of stuff we need to talk about here. If you're losing 15%, I answered my own question. If you're losing 15% each year, how much are you retaining? So you're losing 15%, that means you're retaining what percent of the value? You're not retaining 100 because it's going down by 15%. You're retaining 85%. Okay? So if you're every year, every following year is 85% of the previous year's value. Because you're losing 15%, so you're retaining 85. So your common ratio is going to be, is there a percent button on your calculator? No. So what do we have to do? Decimal. 0.85. See, if the question said that it was gaining 15% each year, appreciated? Is that the right word? Okay, if it increased by 15% each year, then your common ratio would be 1.15 because it would retain the 100% and then grow by 15 more. So 115% of the previous year's value. Okay, but we are decreasing. And usually cars do not grow in worth unless they're very rare, very expensive. Yeah. So, okay, first term. 35,000. Whenever you have time, you need to be super careful. Okay? Because time and your end value aren't always the same thing. So, careful with time. Okay? So, initially the car is worth 35,000, right? The second term, is that year 2 or is that after 1 year? It's after 1 year, right? This would be times 0 initially when you first buy it, or term, well, this is term 1, but times 0, 0 years, right? When you first get it. The second term is after 1 year. So after 1 year, it goes down by 15%. Term 3 would be after 2 years. So you have to be very careful with time. Often time and your end value are not the same. Often your time is 1 less than your end. Because time usually starts at 0, and then 1 year, and then 2 years. But n always starts at 1, and so they don't line up. So you have to be very careful with time. So after 5 years, what's our end value after 5 years? 6. This would be term 6. Okay, n is 6. So although it says after 5 years, that's term 6, because time starts at 0 in this case. Really be careful with time. Really think that through. So now we can find term 6 with our formula. So why don't you solve for term 6 now? Those are great multiple choice questions because often students would put in n as 5 or the wrong r value. So similar idea, the second question, but instead of depreciating, this one's increasing. Navdeep starts a new job that will pay him $60,000 on the first year. So this is $60,000 on the first year. So in this case, does first year and term 1 line up? Yeah, this time it does. So sometimes you have to be careful with time. The difference between after 1 year and on the first year. With a raise of 5% per year, so what would be my common ratio? Okay, would it be 0.05? No, because that would really be decreasing. It would be 1 point. You have to retain the 100% plus gain 5% more. That's 105% of the previous year's value. Well, it's kind of like price with GST, right? You want price with GST, you multiply by 1.05. Instead of just, if you just multiply 0.05, they'll just give you how much you're increasing, but not price with increase. So, yeah. Determine salary in the 7th year. So, 7th year, would that be term 7? Yes, in this case it would be fine. So, go ahead and solve for term 7. You should be able to do that now. So you might need more room or just write small, okay? And maybe at first, yeah, we'll be okay. A ball is dropped from a height of 15 meters. These are very popular questions. They show up on quizzes, unit exams, midterms, finals. They're great questions. I don't know why we love the bouncy balls, but we just love them as math teachers. So a ball is dropped from a height of 15 meters. Well, let's try that again. Okay, so 15 meters. After each bounce, it reaches 3/4 of its previous height. Okay, so here's the first bounce. Then it's going to go up and down, bounce 2, and then 3, and so forth. So if it goes at 3/4 of its previous height, 15 meters. Okay, 3/4. What is 3/4 of 15? How would I figure that out? Yeah, let's multiply it by 0.75. So that means our common ratio is 0.75. What is 15 times 0.75? 11.25. Okay, 11.25. So this one's asking, determine how high the ball will reach after the 7th bounce. Okay, so I'm going to draw 7 bounces. 3, bounce 4, bounce 5, bounce 6, bounce 7, and we want to know how high after the 7th bounce. Okay. So here's my recommendation to you. There's 2 ways to set up this problem, and I find the easiest is always make term 1 after the first bounce. I'll show you if we make term 1 15. I'll do both ways, but it's less confusing, I find, if term 1 is after the first bounce. In this case, how high is that? How high did it go after the first bounce? 11.25. Okay, I'm going to make after the first bounce the first term. Because if I make it the first term, then after the 7th bounce would be the 7th term. And we can even write them out. If we make this term 1 going up, all the ups. So after the first bounce, term 1. After the second bounce, term 2. After the third bounce, term 3. After the 4th bounce, term 4. Term 5, term 6. We are looking for term 7. That's what we're looking for. So n is 7 in that case. Okay, and r is 0.75, 3/4. Okay. So can you find term 7 then? Term 1, 11.25 times common ratio, 0.75 to the power of 7 minus 1. And you're going to see more of these type of questions in your next lesson as well. And so, yeah, you want to get used to them. Let's type that in. Oops. You get 2.0022. Let's go to the nearest hundredth. Let's go is 2.00. Okay. So I'll show you really quickly if you did it the other way. I'm going to skip example 9 for now. We might go back and do it tomorrow. Okay. But if you wanted to make 15 your first term, you have to be really careful. So I'll just show you and then you're welcome to do that. But it's a little bit more confusing. So I'll just draw this out again. 2, 3, 4, 5, 6, 7, and after the 7th. So basically, oops, bounce. So B stands for bounce. It's a bounce number. If you make term 1 15 meters, okay, then basically your downs, all your downs are your terms, right? So your term 1 is what when it falls down. Because when it goes up, it also goes down the same amount. Your term 2 would be here, 3, 4, 5, 6, 7. And so we'd be looking for term 8. Okay, so all your downs are your terms instead of ups. So what it goes up, it also goes down the same. So if you want term 1 to be 15, then n is going to be 8. You're looking for term 8. Your common ratio is still 0.75. And when you type that in, you get the same answer, 0.75 to the power of 8 minus 1. Exact same answer. Okay, so you can make your first term, but I always find it less confusing, a lot easier. And then when it says after the 7th bounce, that's your 7th term. So that's why I like doing after the first bounce, first term, because then those line up, your ends in the question. So that's my preference. You're welcome to do it this way if you want, and that's your call. Okay? So we're going to leave it there because it's pretty long as it is of a lesson.